Welcome to Summarize Science. Have you ever wondered how we can test robots without breaking them or spending a fortune on real-world trials? Training robots to handle complex tasks, especially with soft and squishy objects, is a huge challenge. Testing them in the real world is incredibly slow, expensive, and almost impossible to repeat perfectly. Often, developers use simulations, but there's a big problem called the sim-to-real gap, where a robot that succeeds in a simulation fails miserably in the real world. Well, researchers have developed a groundbreaking new framework to close that gap. First, for the visuals, they don't use traditional computer graphics. Instead, they use a cutting-edge technique called 3D Gaussian Splatting. They simply scan the real-world environment and objects with a phone, and the AI builds a stunningly photorealistic 3D digital scene. This makes the simulation look almost identical to what the robot's camera sees in reality. But looking real is only half the battle. It also has to act real. For the physics of soft objects like this plush toy or rope, they use a system called PhysTwin. It analyzes a video of a human playing with the object to learn its unique properties, like stiffness and friction. This creates a physical digital twin that deforms and moves just like its real-world counterpart. The team combined these two components into a unified simulator and then evaluated several different AI policies on 3 tasks: packing a plush toy, routing a rope, and pushing a T-block. The crucial part is that the AIs were only trained on real-world data and then tested in both the real world and this new simulation to see how well they matched. And the results are nothing short of incredible. As you can see from these charts, there's a nearly perfect correlation between a robot's success rate in the simulation and its success rate in reality. The points on these graphs are tightly clustered around the diagonal line, which means if a robot policy was 75% successful in the simulation, it was also about 75% successful in the real world. This holds true across different tasks and different AI models. When compared to older simulation methods, the new approach is vastly more accurate. The researchers also showed just how important both components are. When they turned off the advanced physics or the special color alignment, the correlation dropped significantly. This proved that you need both visual and physical realism to reliably predict a robot's performance. So, let's recap. By combining photorealistic 3D scenes with physics learned from videos, this framework creates a digital twin of reality that is a trustworthy proxy for real-world testing. This is a massive step forward. It means developers can now test and iterate on new robot behaviors thousands of times faster and cheaper, with confidence that their virtual successes will translate to the real world. This could dramatically accelerate the development of robots that can help us in our homes, factories, and beyond. Thanks for watching Summarize Science.